Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the solutions of important questions of circles. An important advice for me and for everyone. We must be nice to others. This question is from November 20, paper double 1. The diagram shows a circle with center A passing through the point B. A second circle B has center B and passes through A. So this is circle 1 with center at A, and this is circle 2 with center at B. And this is the radius of circle 1 and circle 2. And this is the tangent at circle A to circle A at this point. The tangent at B to the first circle intersects the second circle at C and D. And the coordinates of the centers are given of both the circles. Center of first circle is at A with coordinates -1 and 4, and center of the second circle is at B with coordinates 3, 2. Now the question is, find the equation of the tangent CBD. We need equation of this line. For that, we need to find gradient of this line AB first. So first we will find gradient of AB, because tangent is always perpendicular to radius. So with the help of this gradient AB, we can get the gradient of this tangent. So this is the concept. First find gradient of line AB, and with the help of this gradient get the gradient of tangent. And we have the point 3, 2 because tangent is at B to this first circle. So with the help of this gradient and this point, we can easily get the equation of this tangent. So here is the solution. Gradient of this line is negative half. Therefore, gradient of this tangent line will be 2. The inverse reciprocal of this gradient is 2. And we have the point, we have the gradient, we can easily get the equation. This is the equation of this tangent. Second part, find an equation of the circle with center B. This is so simple. We have the coordinates of center of this second circle. We just need the radius. So we just need to get the length of AB. This length is the radius of both the circles. So first we will find radius, which is AB. Length of AB is radius. And then we have we will use coordinates of center 3, 2. So with the help of radius and this coordinates, we can get the equation of circle 2. This is the equation of circle in completed this square form. So by using these 3 things, number 1 radius, number 2 center, number 3 standard equation of circle in completed this square form, we can get the equation of second circle with center B. So we need radius, and we need to substitute this and this into this equation. This is here. Radius square, radius is under root 20, therefore r square will be 20. And coordinates of center are 3, 2. So by using this as center, this r square 20 into this equation, we can get this equation. This is 20 under root 20. So by substituting 3 here and 2 here and 20 here, we can get the equation of circle 2 with center B. This is the equation of the circle. Now we need coordinates of C and D. See, this tangent intersect circle 2 at C and D. So we just need to solve equation of this tangent with the equation of this circle. So by solving these two equations simultaneously, you can get the x coordinates of C and D. So this is equation number 2, and equation of tangent is y is equal to 2x minus 4. So by solving this equation with this equation of circle, we can get the coordinates of C and D. Solve equation 1 and 2 simultaneously. Here is the solution. Equation 1, equation 2. So by solving these two equations, we have coordinates of C and D, 1 and 5. Because D is lower than C, so the coordinate of D, x coordinate of D should be 1 and the x coordinate of C should be 5, because the x coordinate of C is greater than the x coordinate of D. So the answer is x coordinate of C is 5 and the x coordinate of D is 1. So this question is over. Next question. This question is from November 20, paper 1-2. A circle has center at the point 5, 1 and the point lies on the circle. So this is the rough sketch of the circle. With center at 5, 1 and point A is here. -1, -2, center has coordinates 5, 1. The question is find the equation of this circle. This question is very simple. We have the coordinates of center, we have the coordinates of the point on the circumference, so this distance is radius. So by finding the radius first, we can get the equation of circle. So radius is 3√5, or you can say r square is under √5. R square is 45, sorry. So this is the equation of the circle. X minus 1 plus y minus 5 is equal to 45. This is the answer of part 1. Point C is such that AC is a diameter. So C should be here. And B is the midpoint of these 2 points, so we can easily get the coordinates of C. So first get the coordinates of C. C is x, y. We have B as a midpoint. This is the midpoint, B. So with the help of midpoint 5, 1, we can get the coordinates of C. So you should write 5, 1 here, and x, y. So x minus 1 upon 2, y minus 2 upon 2. This will give you the coordinates of C. And the coordinates of C are 11, 4. Now, show that DC is a tangent and point D has coordinates 5, 16. Let me repeat this part. Point C is such that AC is a diameter. Point D has coordinates 5, 16. Show that DC is a tangent to the circle. So D should be here. This is the rough sketch. Maybe D is here. with coordinates 5 comma 16. It should be here because x coordinate of center and D both are same. We just need to prove this, that DC is tangent. So this is so simple. We have the coordinates of C now. Coordinates of C are 11 and 4. We can easily prove this by finding the gradients of these two lines. To prove that this line is tangent to this circle, we just need to use this gradient of BC or AC and gradient of CD. The product of these two gradients must be -1 if this line is tangent. So gradient of BC is it's half, whereas gradient of DC is -2. So this is half and this is -2, hence shown that this line is tangent. CD is tangent to the circle. So this was part 2. DC is a tangent. This is the way you can easily prove this. Next part. The other tangent from D to the circle touch the circle at E. So this tangent, they are talking about this tangent. This point is E. We did this property in first lecture, that tangents from external point to the circumference of circle are always equal. So we know DE is equal to DC. We need the coordinates of E. For that we must have two equations. So we will form first equation with this fact that DC is equal to DE and the coordinates of E are x comma y. So first thing is DE is equal to DC. Why? Because tangents from external points are always equal. So we will get the first equation with this fact or condition, and the second equation is here. So by solving this equation and this equation simultaneously, we can get the coordinates of E. So DE, this is here. This distance is 180 and DE is this. So DE is x minus 5, y minus 16. This is the distance DE. You can easily get this with the help of distance formula, and this is 180. You just need to cancel these two. So x minus 5, y minus 16 whole square is is equal to 180. This is equation number 2. And this is equation number 1. So you need to make x minus 1 this thing subject. This is this first equation is wrong. It was by mistake. This should be x minus 5 and this should be y minus 1 because the coordinates of center are 5 comma 1. So this is the equation 1. We can make this thing subject from this equation. So by making x minus 5 square subject from first equation, we have 45 minus y minus 1 whole square. So by substituting this value here, we can get this thing. So by solving this thing, we can get y. And after getting y, we need to substitute y here to get x. So y is 4 and x is minus 1. So the coordinates of E will be -1 and 4. You can check this solution first and then the complete solution. This is the complete solution. Next question. A circle with center C has equation. Show that this is outside the circle. This part is very simple. See, circle has center at -8. Sorry, circle has center at 8, 4. To prove that this point T is outside the circle, we just need to, this is rough sketch. We just need to get this distance, CT distance. If this distance is greater than the radius, which is 10, then we will easily show that T is outside the circle. So to prove this thing, we just need to prove this. Distance CT must be greater than radius. So CT is 8 plus 6, 14 square, and 4, this should be 2 square. So this is, I guess, 200 under root. This is 10, I'm sorry, this is not 16. This is radius. And this is tan root 2. This is greater than 10 shown. Next part. Two tangents from D to the circle are drawn. This is the rough sketch. Two tangents, this tangent and this tangent. This is here. Show that the angle between one of the tangents and CT is exactly 45. We have to show this angle. This angle is 45. See, we have this length. This distance is 10 root 2. This is radius 10. And CT is 10 root 2. So by considering this triangle ACT here, see, this is the triangle ACT. And this angle 90, we can easily get this angle. This one is 90. So this is 10, this is 10 root 2. So by using sine into this triangle, we can get the answer. Sine theta is 10 upon 10 root 2, which is 45, hence shown. So we have shown that this angle is 45 and this is 90. So this must be 45 as well, because total angle is 180. So since this is 45, this is also 45, so this triangle is isosceles. So these two lengths must be 10. So this must be 10. And since this triangle is isosceles, so this must be the midpoint of CT. This point. Like these two distances must be same. Meaning N is the midpoint of CT and AB, because this triangle is isosceles. This will help you to solve this part. See, the two tangents touch the circle at A and B. This one. This is the first tangent, this is the second tangent, and they touch the circle at A and B. And this is the midpoint of AB. The midpoint of CT is the midpoint of AB. So the midpoint of CT would be, we have C, we have T, so we can get the midpoint. It should be 8 minus 6 upon 2, that means 1, comma 4 plus 6, 10, 5. So we have got the midpoint of AB. Now we need the equation of AB. For that, we just need to find gradient of CM, because this is 90. Center to chord is always 90, because this is perpendicular bisector. So gradient of CM, first get gradient of CM, and then you can easily get the equation of this line. So gradient of CM will be minus 1 upon 7. Therefore gradient of AB will be inverse reciprocal of this 7, and equation of AB must be 7x minus 2. You can check the solution of this part. This triangle is isosceles, therefore this is the midpoint of CT. Because when you drop a perpendicular from in isosceles triangle from this point to this, you always get the midpoint, because this line is the bisector. So M is the midpoint of CT and AB, and after getting the gradient of CM, you can get the gradient of AB. You have the point, you have the gradient, you can easily get the equation of this line AB. Now find the x coordinates of AB. This is so simple. You can call this as equation number 2, and the equation of circle is equation 1. Solve them simultaneously for the coordinates of A and B. So you need to solve 1 and 2 simultaneously to get the coordinates of A and B. So the answer is 0 and 2. You can check this solution if you want. This is the fair solution, complete solution. First part is here, second part is here, M is the midpoint, and this is the last part, simultaneously. Next question is from June 20, paper 1. The coordinates of the points A and B are this and this. Find the equation of the circle C for which AB is a diameter. This is so simple. You just need to make a rough sketch. A and B, let's suppose A is here with coordinates -1 and -2, and B is here with coordinates 7 and 4, and C, this center is the midpoint of AB, because AB is the diameter. So first we need the coordinates of center by finding the coordinates of the midpoint of AB. So it should be, I think, 3 and 1. And now we need radius. For radius, you can find length of AB and divide it by 2. You have option, you can do anything, AB upon 2 or CB or AC. So radius is, let me check it from the solution, radius is 5. So equation of circle will be minus 3 whole square plus y minus 1 whole square is equal to 5 square. 5 square means 25. You can directly write 25 here. So this is the equation of the circle with AB as diameter. Second part, find the equation of the tangent to the circle C at the point B. So we need equation of this tangent. This is so simple. We just need to get the gradient of AB first to get the gradient of tangent. So gradient of AB. With the help of this gradient, we can get the gradient of tangent, because tangent is always perpendicular to radius. And we have the coordinates of B. So we can easily get the equation of this tangent. Gradient of AB is 3 upon 4. So this is minus 4 upon 3. Finally, we have the equation, which is 3y plus 4x is equal to 40. Next part. Find the equation of the circle, which is the reflection of circle C in the line T. This is so simple. See, this is the first circle, circle C. This is the tangent at B. This is the reflection of the first circle, C. This is the center of first circle. The coordinate of center are 3, 1. And the center and the coordinates of B are 7, 4. To get the equation of this reflected circle, we need the coordinates of this circle, center of the this circle. And this is so simple. You know, this is the midpoint, because in reflection, objects remains congruent. So this circle, when this circle is reflected about this line, you'll get this circle. So both have same radius, because both circles are congruent. So we just need to get the coordinates of center of this new circle with the help of these two coordinates. This is the midpoint of this center and this center. So center of new circle is x comma y, and B is the midpoint. So by using the midpoint formula, we can get the coordinates of this reflected circle. So it should be x plus 3 and y plus 4. So coordinates of new circle are 11, 7. And we already have the radius of first circle, which is 5. So we can get the equation of this circle. So x minus 11, y minus 7 is equal to 25. This is the equation of this circle, which is the reflection of this circle about this line. You can check the solution of this question again. And this is the fair solution, complete solution. Well, next question is from June 20, paper 1 2. The equation of a circle with center C is this. Find the radius and center. Since this is the equation of circle in expanded form, so we must compare this equation with this standard equation of circle in expanded form. So by comparing the x coefficients of x of both the equations, we can get the value of g. 2g is -8, so g is -4. 2f is 4, so f is 2. And c is -5. So coordinates of center are at -g -f. Therefore, coordinates of center will be 4, -2. And this is the formula of radius. G square plus f square minus c. So 16 plus 4 minus c means -5. So I think it should be 25, so 5. So we had to find coordinates of center and radius. This is the fair solution. Next part. The point 1, 2 lies on the circle. Show that the equation of tangent at P is this. This is so simple. This is a rough sketch for your conceptual clarity. Let's suppose this is P and we need to prove the equation of tangent. We have the coordinates of center, which are 4, -2. So we just need to find the gradient of CP first. So gradient of CP is I think it should be 4 upon -3. So gradient of, let me check it. This is right, this is -4 upon 3. So gradient of perpendicular line, which is tangent, it should be 3 upon 4. So equation of tangent would be y minus 2, 3 upon 4, x minus 1. So we have shown this 4y, 3x plus 5. This is the equation of the tangent at P. Shown. Next part. The point Q also lies on this circle and PQ is parallel to x-axis. So let me sketch this to explain this in detail. Rough sketches always help us to understand the situation clearly. Well, the first thing is P is on the circumference. See, this is P with coordinates 1, 2. It says PQ is parallel to x-axis. Let's suppose this is the x-axis. And coordinates of center are 4, -2. And coordinates of Q. See, when line is horizontal parallel to x-axis, then y coordinate is always same. Let me check the coordinates of center. Yeah, 4, -2. It should be 4 and 2. Let me check this again. 4, -2, 1, 2. Y coordinate should be same of both. Y is -2. Yeah, this is -2. It It says PQ is parallel to the x-axis and coordinates of P are 1, 2. Parallel to x-axis means y coordinate should be same. This is here. Y coordinate should be 2. Yeah, it's alright. This is fine. This is not center. Center should be here. I'm sorry, I made a mistake. Center should be here with coordinates 4, -2. This is right. So this since this point has y coordinate 2, so the y coordinate of Q must be 2, because on horizontal line y coordinate remains unchanged. Now how to get the x coordinate? This is so simple. You just need to check this here. This is 1, this is 4, so this distance is 3, so this distance must also be 3, because this is the midpoint. So 1 plus 3 makes 4, so 4 plus 3 makes 7, so this should be 7. Or you can do this in this way. First get the midpoint. Midpoint has coordinates 4, 2, and coordinates of P are 1, 2, coordinates of Q are x, y. So by using midpoint formula, you can easily get the coordinates of Q. In this way, 1 plus x upon 2 is equal to 4, and y plus 2 upon 2 is equal to 2. So you'll get the coordinates of Q. This is the proper way, and this is the according to diagram. So you can do anyway. The tangents to the circle at P and Q meet at T. This is T. For coordinates of T, we need the equations of these two tangents. We have the equation of this tangent. We just need to find equation of this tangent and then solve them simultaneously. So for T, we need to solve equation of TP and TQ. First we need equation of TQ. For that we need to find the gradient of this line CQ. So gradient of CQ is 4 upon 3. So gradient of TQ must be minus 3 upon 4. Equation of TQ is it is minus 3 upon 4x. Yeah, minus 3 upon 4x plus 29 upon 4. So this is equation number 2 and this is equation number 1. So by solving these two equations simultaneously, we can get the coordinates of T, which are 4 and 17 upon 4. You can check this solution again. The first part, we compared this equation with the standard equation and we got the coordinates of center and radius. Second part is very simple. Third part, by using midpoint and diagram and midpoint, we got the coordinates of Q, 7, 2, and coordinates of T. For T, we just need to solve equation of these two tangents simultaneously. First, we need to find the equation of TQ, which is this. This is the complete solution and fair solution. Coordinates of T are 4 and 17 upon 4. Next question is June 20, paper 1-3. I'm sorry. So the first part of this question, the coordinates of 2 points A and B respectively show that the equation of perpendicular bisector is this. This is so simple. Let's suppose this is AB. We need to prove that the equation of this bisector is this. For that we need to find the midpoint of AB first, and then we need to get the gradient of AB. So midpoint of AB, get this. I'm not solving this, you can do this yourself. And gradient of AB, with the help of this, get the gradient of perpendicular bisector, and then you can easily prove this equation. I'm leaving this for you. I just wanted to explain the concept. You can check the solution here. Midpoints coordinates are -1 and 7, gradient is -3/2, and this is the way to prove the equation. I'm leaving the first part. I have explained the concept. Second part. A circle passes through A and B and its center lies on this line. Find an equation of the circle. This is so simple. The center always lies on the bisector. Remember, center of circle always lies on the perpendicular bisector, and it says center also lies onto this line. This is the rough sketch. See, this line is here. So center is the point of intersection of this line and this line. You just need to solve these two equations simultaneously to get the coordinates of center. This is equation number 1 and this is equation number 2. So for the center of the circle, solve the equation 1 and 2 simultaneously. So the coordinates of center are 5 minus 2. For radius, you just need to get either this distance or CB distance. So we found AC, so it's under 13. CA or AC is under root, let me check it, under root 13 or just 13? 13. So the equation of circle must be x minus 5 whole square plus y plus 2 whole square is equal to 13 square, which is 169. So this part was very simple. We just needed to solve this equation and this equation simultaneously to get the coordinates of center, and this is radius. And after getting center and radius, we can get the equation of circle. This question was very simple. And this is the complete solution. First part, second part simultaneous, and that's the answer. Next question. This question is of March 20. First part. A diameter of a circle C1 has endpoints. So this is C1 and diameter has endpoints. So let me make a rough sketch here. So diameter points, you can call them as A and B. -3, -5, 7, 3. We need equation of circle. This is so simple. First we need the coordinates of midpoint of AB. This will be the center of this circle 1, and then we need the radius. So coordinates are 2 minus 1 and radius is under root 41. Radius square is 41. So equation will be x minus 2 whole square y plus 1 whole square is equal to 41. That's the answer of first part. Next part. The circle C1 is translated. This is so simple. You all know this is the way to get the coordinates of circle 2. We need this coordinate equation of circle 2. C. This should be the center of circle 2. So center of circle 1 is at 2 minus 1. To get the coordinates of center of this circle 2, we just need to use translation because this is translated. So center of circle 1 is equal to circle 2, Ct plus C1 C2. So T is 8 and 4. Center of circle 1 has coordinates 2 and minus 1. This will give you the center of circle 2, 10, 3. So center of circle 2 is at 10, 3. So the equation of this circle 2 will be x minus 10 whole square, y minus 3 whole square is equal to radius square, which is 41. Because in translation we get congruent objects. I mean image and object both are congruent. Check the equation. Here is the equation. Next part. The two circles intersect at R and S. So we need show that the equation of RS is this. This is so simple. See, RS is the chord. So from center to chord, and see this is the midpoint. The midpoint of RS, midpoint of the centers of these two circles will be the midpoint of RS. So first we need the coordinates of midpoint of RS. So midpoint of RS can be found by this thing, by taking the midpoint of both the centers. I mean by taking the midpoint of both the centers. So this is 10, 3. When you will take when you will find the midpoint of these two, you'll get this midpoint. So it should be 10 plus 2, 12, 6 and 1. So it is 6 and 1. Now we need gradient of this Cm. So gradient of Cm is we just need to check this. Gradient is gradient should be, let me check the gradient. So it should be 2 minus 1. I think it should be 2 upon minus 4. So 1 plus 1, 2. Let me check this again. 1 plus 1, 2 and 6 minus 2, 4. So it should be 1 upon 2. So gradient of perpendicular line must be minus 2. So equation will be y minus 1 minus 2 x minus 6. So the final equation should be minus 2x plus 13. So this is the way to get the equation of line RS. First get the midpoint of both the centers. This will be the midpoint of RS, and then find the gradient of Cm, and then find the gradient of RS. So this is here. This is the equation. Now find the x coordinates of RS. Show that x coordinates of RS satisfy this equation. This is simple. You just need to solve this equation with equation of circle. This one. By solving these two equations simultaneously, we can prove this. So we just need to copy equation number 1, which is x minus 2 whole square, and the y coordinate is y plus 1 is equal to 41. So we just need to put y here. So we have x square minus 4x plus 4, y is minus 2x plus 14, 41. By simplifying this, we can get the answer. Well, this is all. I hope this lecture will help you to understand how to solve the questions of circles. An important advice: be honest. We must be honest. Best of luck. Allah Hafiz.